we're going to walk through some free body diagram examples just to kind of reiterate a few key things. Let's talk about an object that is sliding down a ramp. Let's say you're moving homes and you have to pack up all your stuff. And when you're unloading your truck to go to your new home, you have this big box that's really, really heavy. So you put it on this ramp from the truck, hoping that it'll slide down. So let's talk about the forces that are acting on that box. The first and foremost one that you should always probably write down is your force of gravity. Force of gravity is always straight down. Okay? Straight down. The next one that you should always take care of is your normal force, which is always perpendicular to the surface. Don't make fun of my handwriting. Now, you have it, if it's moving, let's say that it is slowly sliding down, that means it's going this direction. So there is a force, we're going to call it force 1. You're not really applying the force, so I don't know that I would call it force applied, but if you did, it wouldn't be that big of a deal. But we're just going to say, some force applied is making it slide down. Well, if it's sliding, then you have a force of friction in the opposite direction. What's different about this is you don't just have a free body diagram with something up, something down, something left, and something right. You now have something at an angle. But if you kind of turn your head and let me switch colors, and make this be your y-axis, and this be your x-axis, and you're kind of just shifting your head or tilting it to the left a little bit, what you have is this right here that is an angle just for that force of gravity. So instead of working with 3 different angles, you're only working with 1 angle. And that's going to be super important as we go to the next level with all of this information. And that SOHCAHTOA, I don't remember how to spell the other ones, but that SOHCAHTOA or that trig is going to come in really help. Oh my gosh, I can't even talk today. All right, the next one we want to talk about is just if you have an object just resting and what's acting upon it. So this is acting upon, okay. All right, now we're going to keep looking at this and we're going to talk about the x and the y direction. So we have x and we have y. So your x direction, if you tilt your head, is what I'm circling in blue or writing in blue. So we have force normal. And then our force of gravity is in the x direction. It's just at an angle. We'll get into that later. This was all wrong. I have some editing to do. Okay. Your force is in the x direction. If you tilt your head, it's going to be your frictional force, which is to the right. So it's actually going to be the positive. And your force force 1, which will actually be negative because it's going in the negative x direction. Forces in the y direction would be your normal force and would be your force of gravity. It's just the difference is it's going to be at an angle that we'll get to later. Now, because this object is not bouncing off this ramp, your force normal has to equal your force of gravity at that angle. It's a little bit different because it's at an angle, but those two have to equal. And then your x and y, if it's sliding, your force 1 is a little bit stronger than your frictional force if it's moving. Okay, the next one we're going to talk about really quickly is an object that's on a surface. Just to kind of reiterate that point, this object is not moving. I have two forces on it, force of gravity and normal force. Again, normal force must be perpendicular to the surface. And if this is not moving, then your force of gravity equals your force normal in that y direction.